Hi everyone, my name's Steve Green. I'm a professional drone pilot with SGI UK Drone Services Limited, and I've been operating as a drone pilot for about 9 years now. And in that time, like many drone operators, I've seen the market change in a number of different ways, from the legislation to client expectations and to the uses of drones. We've also seen the payloads and the type of drones expand from a few smaller drones up to a whole enterprise level with LiDAR and gas detection. What I wanted to produce was a series of videos that don't look at the legislation side of it, because there are other operators that do that far better than me, but explains a little bit more about the process from when the client comes to me with a job right the way up to the data capture, the processing and the deliverables that I send back to them. Now, I appreciate that every drone pilot will have their own way of doing things, and it isn't a one-size-fits-all, so you have to adapt the process to make it usable to you. This particular video is about the pre-flight preparation, the stuff that you do before you leave for the site. And it's about the preparation that's needed to get your paperwork together, so that you can give as well a quote that reflects the amount of work that is going to be needed for that particular job. Now, this video covers the pre-planning state, as I've already said. But why is it important? Every successful drone flight that you'll carry out starts with pre-planning, and it starts a long time before you get onto site. Good planning improves the safety and the efficiency of the job, but also it improves the quality of the results to make sure that the client gets what they're after. And that's the key thing. Now, like with all process, there are a number of starting points, or a number of points to consider. And the first one you have to ask yourself is about the client requirements. What is it they're trying to do? What are they going to use the data for? What do they want from you? It could be that they just want some images from inside of a building, or photographs of development, progress tracking, pile volume calculations, and marketing information. You can't conduct a drone flight successfully without understanding what it is they want from you, and that is the key thing. That leads into what deliverables they will expect. In other words, what results. Whether they want an orthomosaic map, a 3D model, a point cloud, a CAD overlays, inspection photographs, a thermal report, or a volume calculations. It all denotes or dictates the type of settings that you have, and indeed, in some respects, the type of drone that you'll use. You need to understand the level of accuracy that they're required. So, for example, pile volume calculations require probably less accuracy than, let's say, a model that's going to be used to get topographical data for a building development. This denotes whether or not you use RTK, whether you use PPK, and how many ground control points are. Now, I didn't say whether or not you use ground control points. In my belief, in this type of work, ground control points are as essential as the drone itself. Without them, there is no degree of accuracy that can be guaranteed in any way, shape, or form. You also need to understand the type of coordinate system that they're using. Majority of CAD work for building developments, for example, is done in OSGB 36. But your drone records the EXIF data on the images in WGS 84. And a GNSS receiver, like the MLID 2 RS2 that I use, can produce a myriad of coordinate systems. And you need to understand the difference between the two, how to convert them if need be, whether or not you need to convert them, and you need to understand the process of doing that. Finally, and perhaps the most important, is you need to manage their expectations of what can be done. You've got to be able to deliver on what you offer them, otherwise they're not going to come back. Now that we know what the client wants, we need to understand where they want you to fly. So you need to look at the location. So most of my clients will send me a grid coordinate or an address, but it doesn't really tell me what area I'm going to be flying over. So I normally ask for something that shows the boundaries of the sites, and it can be a CAD plan or even a Google Earth image with the boundary drawn on. Either way, it gives you an idea of the type of area you're going to cover. You need to ask about timescales. Is there a specific time that you want me to be there, or can I just go whenever the weather's good? You also need to identify any constraints on the site. So, for example, restricted access, trees, tall trees in particular, pylons, electricity cables, sites of special scientific interest. All of that needs to be taken into account. So now we've got the location, we need to check the airspace. Now in the UK, the airspace is divided into groups. I'm not going to go too much into that, but you need to check that you can legally fly in that airspace, whether or not it's in a flight restriction zone, whether it be a temporary one or a permanent one because of an aerodrome or a prison, for example. And to do this, I usually use a number of different apps on my phone. I have the Drone Assist app from NATS on my mobile device, but you can also use the Drone Safety Map. Now, the Civil Aviation Authority require that all drone operations have landowner permission. It's a phrase that they use quite often. That landowner permission can be directly or indirectly. And what do I mean by that? Well, you can have landowner permission from the agent that's under contract to buy the land, should they get planning permission, because they will have had permission, for example, a survey to be carried out. The next part we need to consider is the mission planning itself. The overall objectives, and this covers things like the type of payload you're going to use and the settings that you will have within the camera itself. So for example, if you're covering an area which is forested or has long grass, LiDAR would be a better option because it gets a greater penetration of into the ground levels to give you a true ground level. Photogrammetry works better on areas that are more open, where the field is perhaps had the grass cut, the grass is shorter or turned over. It doesn't really matter. The mission planning also denotes the overlap. Now, for me personally, on the overlap, I will use 70-80 as a minimum, but I may go further depending on changes in elevation on the site and the site characteristics in general. Your battery requirements. You need to understand how they are going to be affected by things like weather conditions, whether it be strong wind or cold weather. And so you need to plan your battery requirements accordingly. Something else that needs to be considered, but although it'll be closer to the time of flight, is the weather. Now you're looking for things like the wind speed and visibility and rain. But two of the other things that you need to consider, and for me they are very important, are the KP index and the dew point. Now the KP index is a measure of the electromagnetic activity that can be expected at any one time. And it's measured on a scale of 0 to 9, 0 being absolutely nothing, but 9 being don't bother getting your drone out of the case. For drone flights, for me again, anything above a 3 or a 4, I will use extreme caution. When I get to 5, I don't bother. It's too dangerous. If you're carrying out a solar inspection, then you need to consider the solar angle. So you need to consider the angle of the sun at the time you intend to fly compared to the panels. And you also need to consider thermal loading on the panels, but that's a video for another day. Now the dew point, as I'd already mentioned, is the temperature at which the air becomes saturated with moisture. And it's very difficult to sort of explain it any differently than that. The examples that I'll give is simply this. If you take your drone out of a nice warm car, and it's been sat in there for a couple of hours, and it happens to be a cool, crisp morning and the dew point is quite high, when you set your drone up, you will get condensation on the lens and potentially condensation on the electronic components within the drone itself. And so it does need to be considered because this can affect the safety of the flight and the quality of the data in which you're delivering. Next, you need to consider the site assessment itself. Now for this, I would use Google Earth or Google Maps. It doesn't really matter which you use, I tend to use. Now Google Earth and Google Maps have the ability to allow you to manipulate the plan in such a way that you can maneuver around and see the fields or the area that you're interested in from different angles. You can then see where the public access is. You can see whether or not there are any pylons on site. You can see if there's any smaller, lower power lines or phone lines. Whether or not there are any buildings that are going to obstruct your view of the drone, how tall the trees are. All of this information you can get from Google Earth and Google Maps. But perhaps most importantly, what you can also get from Google Earth and Google Maps is elevation changes. And you can see that on the bottom right corner of the screen when you're looking on Google Earth. As you move the mouse, the figures change on the bottom right corner, which tells you the elevation. So you can figure out what the elevation change is. Where there is a severe elevation change, you might want to split the flight up into smaller areas to be covered. Where the ground is nice and flat and you've got no trees to block your view or anything like that, you could perhaps do the same size flight as a single job from one takeoff and landing point. Now there is a second part to the pre-flight assessment which is done on site, because Google Earth and Google Maps can be up to 5 years out of date, and it is again something that needs to be remembered. So now we come along to the final bit, the checks. These are the checks that I would do before I leave the house to make sure that I've got all of the equipment that I need, and I've got enough batteries and I've got enough SD cards to cover or to hold the data that I'm going to be capturing. Now sometimes you only fly 200, 300, 400 images. Some of the sites I do are 10,000 images. So you need to be able to store that, but you also need battery power. Do you need to take the charger with you, or can you just take the batteries in a storage case? Do you need all of the batteries or just some of them? Is it better to take all of them? Usually it is for me, and that's what I do. And then perhaps the single most important thing to do or to remember is that only if you are 100% confident that the flight can be carried out in a safe condition and without incident should you go ahead. If you are not happy, do not fly. It is as simple as that. Now, spending 20 minutes planning or an hour planning can prevent costly mistakes like having to revisit the site. But most importantly, it improves your safety record and it delivers the clients the information that they wanted at the quality that they wouldn't get from anyone else. And always remember that. Now, as I've said, these videos are going to be, I'm going to do a few of these videos. I realise my voice is a little bit monotone, but I will try and work on that. There are some useful information sites that I've put on in the link below and on the end of this video. And if it's something that you're interested in, please leave me a comment if you think I've missed out on something, or if you make any suggestions. Just leave a comment in there below, and I will produce the next video as soon as I get round to it. Thank you. Bye.